Now you see, let us understand what do we mean by continuity and differentiability. So a function y is equal to f of x is said to be continuous in an interval if for every value of x in that interval y exists. So if we plot the points, the graph without lifting the pencil. Okay. So if we have to lift the pencil on drawing a curve, then the function is said to be discontinuous. So that is the main difference between continuity and discontinuity. And mathematically, how can we say that a function is continuous? If limit extends to a minus f of x, limit extends to a plus f of x, and f of a exist, and all the three are equal. Like this, limit extends to a minus f of x is left hand limit. This is equal to limit extends to a plus f of x, that is right hand limit, and that is equal to f of a. Then you can say that it is continuous. Okay. And discontinuous, if it is not equal, it is discontinuous. Okay. Now there are some properties of continuous functions. Like if let's say f and g are continuous, then f plus g is continuous at a, f minus g is continuous at a, f into g is continuous at a, and f by g is continuous at a. But in division, provided g of a is not equal to 0. And one more property is c into f is continuous at a where c is a constant. And mod f is continuous function at a. And you need to remember few points. Every constant function is a continuous function. Every polynomial function is a continuous function. Identity function is a continuous function. And every logarithmic and exponential function is a continuous function. Okay. Next, coming to some important series. So you should be aware of these series. 1 plus x whole power n is equal to 1 plus nx plus n into n minus 1 by 2 factorial x square plus n into n minus 1 into n minus 2 into x cube by 3 factorial plus so on. This is one formula. And the second one is e power x is 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus so on up to infinity. And e power minus x is alternate plus minus signs you will get. Like 1 minus x by 1 factorial plus x square by 2 factorial minus x cube by 3 factorial plus so on. And the third formula is a power x is equal to 1 plus x log a to the base e plus x square by 2 factorial log a to the base e whole square plus so on. And log mod 1 plus x is x minus x square by 2 plus x cube by 3 plus so on. Now take the next formula. Log mod 1 minus x expansion is minus x square by 2 minus x cube by 3 so on. And sin x formula is x minus x cube by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial plus so on. And cos x expansion is 1 minus x square by 2 factorial plus x power 4 by 4 factorial minus x power 6 by 6 factorial plus so on. And tan x is x plus x cube by 3 factorial plus x power 5 by 5 factorial plus so on. Now take this very, very important formula, that is differentiation from first principle. First principle model is very important. So we use this formula. like derivative of f of x, that is denoted by f dash of x, that is limit x tends to 0, f of x plus h minus f of x by h. Now I will give you some useful formulae for differentiation. That is d by dx of constant is 0, d by dx of x is 1, d by dx of x square is 2x, d by dx of x cube is 3x square, d by dx of x power n is n into x power n minus 1. Then d by dx of e power x is e power x, d by dx of a power x is a power x log a, d by dx of root x is 1 by 2 root x, d by dx of sin x is cos x, d by dx of cos x is minus sin x, d by dx of tan x is secant square x, d by dx of cosecant x is minus cosecant x cot x, then d by dx of secant x is secant x tan x, then d by dx of cot x is minus cosecant square x. These are the most important formulae. So let's get started with the problems. Take the first question. Find all points of discontinuity. Find all points of discontinuity of f where f is defined by the following function. F of x is equal to mod x plus 3 if x less than or equal to minus 3. Minus 2x if minus 3 less than x less than 3. 6x plus 2 if x is greater than or equal to 3. So let's see how to start this problem. We know that mod x is continuous function, right? Mod x is continuous function. So f is continuous for all x is less than minus 3. Okay. Now coming to the second function, minus 2x is continuous everywhere. So f is continuous for all x, that is x lies in between minus 3 and plus 3. Then coming to 6x plus 2, as we know 6x plus 2 is polynomial. So it is also continuous everywhere. So f is continuous for all x where x is greater than or equal to 3. So we have shown that all the three functions are continuous. Now we need to check left hand limit and right hand limit. Now we have to check the continuity of the function at 2 points. That is x is equal to 3 and x is equal to minus 3. So at x is equal to minus 3, what is f of x? Just look at the functions. F of x is mod x plus 3. So f of minus 3 will be mod minus 3 plus 3. That is 6. Now what is left hand limit? How to choose left hand limit? This is the representation. Limit x tends to minus 3 minus f of x. So here we need to choose a function where x is less than minus 3. So what is the function over here? That is limit x tends to minus 3 minus mod x plus 3. So that is mod of minus 3 plus 3 which is equal to 3 plus 3, that is 6. And what is right hand limit? Representation is limit extends to minus 3 plus f of x. That is limit extends to minus 3 plus. Now which function do we choose? Where x is greater than minus 3. So what is the function? It is minus 2x. So that is minus 2 into, in the place of x we put minus 3. So that is 6. So you can see left hand limit is equal to right hand limit. So, and this is equal to f of minus 3. Left hand limit is equal to right hand limit, and that is equal to f of minus 3. So it is continuous. So it is continuous at x is equal to minus 3. Now we need to take at x is equal to 3. What is f of x? F of x is 6x plus 2. Look at the functions. So that is 6 into 3 plus 2. That is 20. Now if you find left hand limit, you get limit extends to 3 minus f of x. Now which function do we choose here? Where x is less than 3. So limit extends to 3 minus 2x. That is minus 2 into 3, which is equal to minus 6. Now the same way we will find out right hand limit. Right hand limit is limit extends to 3 plus f of x. So in which function you have x greater than 3? That is 6x plus 2. So limit extends to 3, 6x plus 2. That is 6 into 3 plus 2, which is equal to 20. So you can see left hand limit is not equal to right hand limit. So it is discontinuous at x is equal to 3. So they are asking us the points of discontinuity. So we need to mention it is discontinuous at x is equal to 3. Now take this next question. Find all points of discontinuity of f where f is defined by this function. F of x is x by mod x if x is less than 0 and minus 1 if x is greater than 0. So let's see how to begin this. So for x is less than 0, f of x equals x by mod x is continuous. It is continuous for x is positive. So f of x is a constant function because x and x will get cancelled. So it is continuous. Now we shall find at x is equal to 0, is it continuous or discontinuous? So let's find LHL, that is left hand limit. So how do you represent it? Limit extends to 0 minus f of x. So which function you have x less than 0? That is the first function. So you get limit x tends to 0 minus x by mod x. That is limit extends to 0 x by mod x is minus x, because here x is, you have 0 minus, which means it is less than 0. So mod x will become minus x when x is less than 0. So x and x cancel, the answer is minus 1. Why did we use this condition? Since mod x is equal to minus x when x is less than 0. Now we need to find right hand limit. So right hand limit is limit extends to 0 plus f of x. So that is limit extends to 0. Which function do we choose? Where x is greater than 0. So that is minus 1. So the answer is minus 1. And f of 0 is also minus 1. Therefore, limit extends to 0 minus f of x is equal to limit extends to 0 plus f of x, and that is equal to f of 0. Therefore, f of x is continuous at x is equal to 0. Hence, f of x has no points of discontinuity.